In the 19th century, there were no electric drills, no CNC machines, no laser levels, no power tools as we know them today. And yet, during this period, humanity built structures that still stand. Bridges spanning hundreds of meters, stone buildings with millimeter-level precision, metal frameworks assembled with exact tolerances. When people see these structures today, a common question arises. How was this built without modern tools? The answer is not mystery. It is skill, systems, and forgotten methods of work. The illusion of primitive technology. The 19th century is often imagined as technologically crude. This is misleading. While electricity was limited, mechanical technology was highly advanced. Engineers relied on geometry, mechanics, repeatable processes, human skill refined over centuries. Precision did not begin with electricity. It began with measurement. Measuring without electronics, accurate construction starts with accurate measurement. By the early 1800s, builders had steel rulers, calipers, micrometers, plumb lines, spirit levels. Surveyors used theodolites chains with standardized links, optical sighting tools. These instruments allowed angles and distances to be measured with surprising accuracy. Railroads, canals, and bridges could not exist without this level of precision. And they did. Stone cutting. Slow, not crude. Stonework often looks impossible by modern standards. Perfect joints, smooth curves, massive blocks aligned without visible gaps. This was achieved without power tools, but not without technology. Stone was cut using iron and steel chisels, mallets, wedges, saws with abrasive sand. For hard stone, the process was gradual. Cut, test, adjust, repeat. Precision came from time, not speed. A single stone block might take days or weeks to finish. Templates instead of machines. One key method was the use of templates. Before cutting stone, full-scale wooden templates were made. Angles and curves were verified. Physically, errors were caught early. This eliminated guesswork. Every stone followed the same reference shape. The result was uniformity, without automation. Why joints look too perfect? Many 19th century stone joints appear seamless. This was intentional. Builders used surface grinding rubbing stones together with abrasives test fitting multiple times. The goal was maximum contact between stones. This increased stability and reduced the need for mortar. What looks impossible today is simply careful manual fitting. Metal without electricity. Metalworking in the 19th century was already industrial. Iron and steel were produced in blast furnaces, rolling mills, foundries by mid-century. Standardized beams, plates, rivets were mass-produced. Factories were powered by steam engines, water wheels, electricity was not required. Rivets, instead of welding, modern builders often underestimate rivets. Riveted structures include bridges, ships, towers. Hot rivets were placed glowing red, then hammered into shape. As they cooled, they contracted, pulling joints tightly together. This created connections that were strong, flexible, durable. Many riveted bridges still outperform modern welded ones. Bridges without computers. Consider 19th century bridges. Engineers calculated loads using mathematics, material testing, safety margins. They built scale models. They over-engineered intentionally. Stone arches distributed force naturally. Iron trusses balanced tension and compression. No computers, only physics. Machining without electricity. Lathes, milling machines, and drills existed long before electric motors. They were powered by belts, shafts, steam engines. Entire factories ran on centralized mechanical systems. Precision machining was slow, but consistent. Once set up, machines could produce identical parts all day. Why tolerances were so tight? Industrial systems required compatibility. Railroads demanded standardized tracks, uniform wheels, precise spacing. This forced manufacturers to develop high precision. If parts didn't fit, the system failed. Precision was not optional, it was mandatory. Skilled labor, not mass automation. Another key difference was labor. Craftsmen trained for years, stonemasons, machinists, metalworkers, carpenters. Their skill replaced what machines now do. Hands were the final calibration tool. Why this level of skill disappeared? Many of these methods declined, not because they failed, but because they were slow and expensive. Electric tools increase speed, not necessarily quality. Modern construction optimizes for time, cost, scalability, not longevity. Surviving structures are the best ones. We often compare modern average buildings to historical masterpieces. This is misleading. The buildings still standing today are the best constructed, the most maintained, the most important poorly built structures from the past collapsed long ago. Survivorship bias makes the past look better. Workshops behind the scenes. Behind every monumental structure were workshops, stone yards, metal shops, foundries. Components were prepared in controlled environments, then assembled on site. Construction was not improvised. It was industrial, just slower. No shortcuts, only process. 19th century builders followed strict processes. Measure, cut, test, adjust, repeat. Mistakes were corrected early. Nothing moved forward until it fit. This discipline created results that still impress today. The real difference from today. The difference is not technology. It is priorities. Modern construction values speed. Historical construction valued permanence. Both are logical for their time. What this teaches us, the past was not less capable. It was differently optimized. Precision does not require electricity. It requires knowledge, patience, systems. The structures left behind are proof. When we ask, how was this built without modern tools? The answer is simple. It was built with time, skill, and methods we no longer use. Not because we cannot, but because we choose not to.